Welcome to the Embodied Titration experiment. Our goal is to create accessible and affordable 3D printed chemistry equipment for learners of any age. The Meteor studio at ASU designed and printed the 3D burette in this titration experiment. Turning the stopcock at certain speeds controls the speed of the solution coming from the virtual on-screen burette. The goal of the Embodied Games lab is to understand how having a physical, kinematic, and tangible interface like the 3D printed burette affects learning compared to using a low embodied interface. The low embodied interface here is pressing keyboard arrows. Participants are randomly assigned to a 1-hour experiment that includes pretests, reading about titration, and performing 2 titration tasks within the simulation. At post-test, participants recall what titration is, and their verbal responses and gestures are recorded.
It's done by slowly adding the NaOH into the HCl using your burette.
We're also analyzing if those in the high embodied group recreate the stopcock turning gesture more often. Our hypothesis is that those who use the 3D printed burette in the experiment will score higher on a chemistry content knowledge test and use the turning gesture more during recalls. Before showcasing some results, we highlight where the study lies along the XR spectrum. Within the realm of mixed reality, this study falls towards the lower range of haptic embodiment because there is little dynamic force feedback. However, the shape of the device and type of gesture done are highly congruent with what is done in real-world wet labs. Our results, gathered with 138 graduates randomly assigned to either the keyboard or 3D burette conditions, were nuanced. If we break students into lower and higher prior knowledge groups, it appears that the higher prior knowledge students perform significantly better on the knowledge test when they use the 3D haptic device. Notice that the blue line is higher than the orange control line in the higher range of pretest scores. This is called a two-way crossover interaction. This also suggests that lower prior knowledge students did better when they were on the control device, when they were on the keyboard, that is. This was not a novel input device. One hypothesis is that students with less knowledge may need some pre-training to bring them up to a certain competency before placing them on more novel and multimodal input devices. Students gave recalls and we scored verbal idea units and the types of gestures they used. You can see in this 2D projection called an epistemic network analysis that the two groups gave recalls in a different manner. The experimental group used the stopcock turning gesture significantly more often than the control group. That is coded as G3, and it is pulling the haptic group's performance significantly along the x-axis. During post-test, all participants were exposed to both interface devices. We show that overall, the majority of participants in both groups preferred using the 3D printed burette to the keyboard device.